I'm Anil Kumar, and with the help of this video, we should understand the concept when to use permutation and when to use combination. There are two examples here which we are going to discuss. Part A. How many ways can a teacher select 6 students from the class of 30 students if the youngest and the oldest must be included? And the second question here is, a set has 4 distinct elements. How many subsets are there? So these are the two questions for you. Now, to understand whether we should use permutation or combination, we have to ask a very simple question. And that is, will the order matter? Now, the question here is, how many ways can a teacher select 6 students from a class of 30 students? So you are selecting 6 students. Order of this 6 students, will it matter or not? That is the question. So we know order will not matter. So order will not matter, right? So that is one thing. Since order does not matter, we have to use combination, right? Not permutation. Okay, so that is a question based on combination. And what are we doing here? We have distinct students. All 30 students are distinct. So we have distinct students. And in that, we are selecting some out of all. So not all of them. We are selecting 6 out of 30, right? So we are selecting R in a way, right? So therefore, the formula to be used is NCR, right? NCR. Since we are selecting 6 out of 30, not all of them. So that is how we approach a question. And now let's look into further conditions given in this question. It says, how many ways can a teacher select 6 students from the class of 30 students if the youngest and the oldest must be included? So that means amongst 6, we already have 1 which is youngest, 1 which is oldest, right? So basically, we are selecting how many? So we are selecting 4 students in a way, right? Effectively, we are selecting 4 students from 30 take away 2. So we have taken away these 2 from 28 students. So that gives us that the value should be from 28 students, 28C4. So that is the answer for this particular question, correct? So that is how we need to approach. Now let's look into the second one. You should calculate this value. I'll do the calculation later. Part B is a set of 4 distinct elements. How many subsets are there? Now, in a set of 4 distinct elements, we could also take it as a combination. These are 4 distinct, right? And we are taking how many? All possible, right? So that is 2 to the power of n, right? So this is the case where we are taking all possible combinations, right? That means we are also including the null combination. So it is just 2 to the power of n. Since we are including null set. Null set means that none of those 4, right? So that is 4. So the answer here is, since n equals to 4, the solution is 2 to the power of 4, which is 16, right? And now let us use calculator, find the answer for the first one, which is 28C4. So it is 28C4 equals to 2475, right? So that is how we can answer such questions. I hope that is absolutely clear. So this video actually gives you 2 cases of combinations where we are working with distinct elements, right? And in the first case, we are selecting some from the others with a condition. And in the second, what we are doing is we are finding all possible combinations, right? So that is how we can actually understand better how to use combination. I hope that helps. I'm Anil Kumar. You can subscribe and share my videos with your friends. Thank you and all the best.